Hello and welcome to Easy Projects. So this is part 2 in the remote controlled Arduino robot series, and in this video we'll be writing the code for the robot that we built in part 1. As I mentioned in the previous video, we'll be controlling the robot with an Android mobile phone, and we'll be using the app called Arduino BT Joystick Free, and this is a very simple way of sending serial commands via Bluetooth to the Arduino. There are some more advanced apps available that can do more stuff, but let's start with a simple one. So let's first quickly take a look at what data is sent from the phone to the Arduino, and we can do that by using the USB connection and print it to the computer. We will take a look at how to make the connection between the Arduino and the phone later on. So I connected the robot to the computer with the USB cable, and I uploaded this piece of code that you see here. It basically just reads whatever's on the Bluetooth and sends it over the serial port, the USB cable to the computer. But let's open the serial monitor and see what we get. I already connected the app to the robot. So we get a bunch of data here. Let's stop the scrolling. So you might think this looks a bit weird at first. It says b equals 0, hashtag, hashtag, b equals 0, hashtag, hashtag. And this is when no button is pressed. So it sends a signal saying that we're not pressing any button. And that's actually very useful when we're going to write the program. So now I'm just going to hold down the forward button. And then let's try reverse maybe. And then we can scroll back through the data. And you can see when we press the button, it changes the 0 to a 1 for forwards, and back to 0 when we release, and it says 2 when we reverse. So all the buttons here have different numbers, of course, and you can see what that number is in the settings of the program. But to get a useful reading of this, we will need to find some way of getting rid of the hashtags, the b and the equals, so we only have the number of which button was pressed. So I think that should be the first thing that we do. But we will need to make a Bluetooth connection, of course. So let's start there. So as I mentioned, the Bluetooth modules has a standard serial interface. So the only thing we need to note is where we connect the RX and the TX pins. And on my robot, I connected them to pin 2 and 3. So I went and created a new Arduino project here. And to get the serial connection to the Bluetooth module, we'll need to include the software serial library. So the software serial.h. So now we can make a software serial object, and let's call it BT for Bluetooth. And now we need to specify which pins we used. And my pin 2 was the RX and pin 3 was the TX. And TX goes first. So now in the setup code here we can start the serial connection. And if you have used the USB serial connection to connect to the serial monitor here, it's exactly the same, except now we use BT instead of serial. So BT.begin. And then we need to specify the baud rate, which will be 9600. You can change this in the Bluetooth module, but we will not go there. You just need to make sure these match both in the program and in the actual module. And the default is 9600. So this establishes the connection and lets us send and receive data. So down here in the loop code, we want to check if we receive any data, and then we want to do some actions accordingly. But before we read the data that was sent to the Arduino, it's a good practice to check if something is available. A lot of times the read call will be a blocking function that waits until something is actually sent so that it can read it back. I'm not entirely sure if the Arduino does that as well, but checking if there is something definitely doesn't do any harm. So we can do if, and then bt.available. So this function will return the bytes that are available to read, So if that is 0 bytes, then we will not read. So this will be 0, it will return 0, and the if statement will be false. Then we'll just skip across it. If there is 1 or more bytes, then we will read it in here. So we make a character, let's call it input. And we want to set that equal to bt.read. So we already know what we're going to receive. It's going to be one of a few predetermined integer values representing which button we pressed. So the easiest way to check is with a switch. And input. And then we have the cases from 1 to 9, and 0 means we're not pressing anything. And it has to be the character 1, so you need the single quotes. And if I remember correctly, 1 is forwards, so we will make a new function called forwards. We'll make that later. And then we will break the switch. And then we have case 2, which is backwards. We'll call that BW. So left is number 3. And right is number 4. So I think we'll just use these buttons to begin with, and then we can add some more functionality later. We would also want a default case. So this will take 0 and all the other values into account, no matter which value we sent. And then we'll make the robot stop. It looks like that's already a function, but if we declare it in... It looks like that's already a function, but if we declare one in our program here, it will use that one instead of whatever this refers to. But you should remember that the Arduino Bluetooth joystick doesn't just send this character, it sent the hashtag b equals and then the number. So we need to filter that out somehow. One way could be to create a case for 0 and then write the stop function in this one. And then just have no default. Or we could undo that and filter it before we get to the switch case here. So what we can do is to make a while loop that will run when bt.read does not equal the equal sign. You could just end the while loop right here, but to make it clear what I'm doing, I usually write continue like this, so it doesn't look like just a mistake with a semicolon right there. So what this while loop does is it reads what's coming in on the Bluetooth, and as long as that is not an equal sign, it just continues to read. When it is an equal sign, the loop will break, and we will read once more, and that will give us the number that we're after. By doing the multiple reads here in the loop, we kind of violate the law that we set up here that we wanted to check if the Bluetooth is available, because it might only send 1 byte when we're getting to this if statement. And when we're reading, we want to read, 4 bytes or 5 bytes actually. But we know that the app is sending the characters in bursts, so it doesn't really matter if we have to wait a few milliseconds here. It's just this ensures us that we're not in between the bursts and waiting like half a second before we get the next one, or 1/10 of a second, or how often the app will send the data. So I think this way of filtering it is better than the other, because this way we only send the data into the switch case that we actually need, instead of putting the equal and the hashtag through this as well. But you can only do this as long as you know exactly what you're going to receive. So now we need to make the forwards, backwards, left and right and stop functions, and I'll make the prototypes up here. And in order to control the motor, we need to set all the pins that we use to connect to the motor controller to outputs, and we'll do that here in the setup. And we do that with the pin mode function. And then I use pin 5, 6, 9 and 10. So we could write pin 5, and we want that to be an output, like this. But if you have a lot of pins, you might get confused as to which pin does what. So you can predefine these, so you can use text instead, and that way we make it a little bit simpler. So if we do some defines up here, then we can call it M1A, for example, for motor 1, pin A. And that goes to pin 5. And then we have the M1B, which goes to pin 9. And then we have the M2A and B. So that's pin 4 and pin 10. Now, as I mentioned in the first video, one of these pins can be a regular digital output, but one has to be a PWM output. That way we can control the speed of the motor. And now here, instead of remembering the numbers, we can just write M1A, M2A, M2B, and M1B. And now once this has been sorted out, we can start to make the actual functions. And I think I'll put them down here. So let's try the first one. In the first video, I also mentioned that in order to get the motor to turn, one pin has to be high and the other has to be low. Which pin is high and which pin is low determines which way the motor is going to spin. So for the forwards, I want the digital pin to be low and I want the PWM to be high. And I chose the PWM pins to be the B pins on the motor. So we'll do a digital write. And M1A, comma, and you can either write low or just 0. And to set the PWM value, we'll do an analog write. M1B. And then it has to be a value between 0 and 255. So 255 will be fully on. We'll just do that to begin with. And then the same thing for the second motor. And this is our forwards function. We can always change this later on to do acceleration and stuff like that, but let's just keep it simple to begin with. And this is the data sheet for the chip that we're using, the one that is on the motor controller PCB. You can get all the specs here. So let's make the reverse function just by copying this. And calling it backwards. And then change this to a 1 and this to a 1. Now the PWM value, we can just change that to a 0 and that will work fine in this case. But later on, if we want to control the speed of the motor, we have to be a little bit more clever than that. because now that this is a 1, then the PWM has to be inversed as well. So what we want to do is to set 255 and then minus the speed. And in this case, our speed would be 255. So this will still be 0. But let's do it this way, then we don't forget later on what we mean by this. And so now let's make the left function. Again, we'll copy and paste it. And now the right motor has to go forwards, and then I'll make the left motor go backwards slowly in order to turn to the left. So my right motor is the motor 1. So we'll make this go forwards. So we have to put a 0 and a 255 here. But I think maybe 255 full speed will be a little bit too fast when we are turning. So let's put this to 100 instead. So this will be a little less than half the power going to the motor. And the other one we want to go backwards. And we want it to go backwards at maybe a little less than we are going forwards with this one. So let's put it at 75. And again, we have to subtract our value from 255, because when this pin is high, then as long as this pin is high, the motor will be stopped. So it's the off period here that sets the speed of the motor. And then for the right function, we'll do exactly the opposite. So we'll put a 1 there. We'll put this value up here. We'll put a 0 there and a 100 down here. So now we only have the stop function left. And for this, we can simply make everything 0, and then the motor should be stopped. Like that. So there is one more thing that we need to consider, and that is the frequency of the PWM signal. If this is too fast, then the transistors inside the controller doesn't have time to turn on and off, and they will be in the linear range too much of the time, so they will heat up and get very warm, and you can burn them out if you're not careful. I think the standard frequency for the Arduino is pretty low, but if you use another microcontroller, it could actually be in hundreds of kilohertz, and that would be too much for these controllers. They would overheat and burn out if you use them for bigger motors like this. One way to find out for sure what your frequency is to just search Google for Arduino PWM Frequency, and then one of the first results will be this timer PWM Cheat Sheet, which will show you the values and also how to change them. So you can see for pin 9 and 10, the ones that I'm using, the standard value is 490 Hertz, and that should be good enough. But there isn't any reason really why we couldn't lower it to 122.55 Hertz. The only thing that you have to be careful about is not to change the timer 0 frequency, because this is used to run the internal timing of the Arduino. So the millisecond delay, and if you want to get the number of milliseconds since the device was turned on, this will all be off if you change this frequency. But this one down here doesn't impact that. So perhaps you shouldn't choose pin 5 or 6 for the PWM pins. I think we'll go ahead and change it to 122.55. So you can just copy this line of code down here and then remember your setting. So 4 in hexadecimal. And we'll put this into our code. So in the setup here, as the first thing, we will write this and then 0x04. And this will lower the frequency to 122.55. So unless I made any mistakes, which I hope I didn't, I think we're ready to test it. So let's check the syntax at least. So it compiled just fine, and now I'll try and upload it to the Arduino. Or maybe not, because I'm using the USB cable for the microphone. Let me get another one. Okay, so let's take a look at it here. I uploaded the program to the robot, as you saw, and now we're going to power it up. And we can see the Bluetooth module is flashing. It always does that, by the way, when you power it up, and it's ready to receive a connection. Now you connect with the app here, and now it's lighting up solid, meaning that you have a valid connection. First time you connect, you have to enter the password for the Bluetooth module, which is 1234, if I remember correctly. And you can also change that, actually. Maybe I should do a video on how to change the name and password and baud rate of this device. It's not really that difficult, but we can do it at another time. But now the moment of truth. Will it work? So let's press the... No. How disappointing. Well, time for debugging then. So I'll probably be able to figure out what's going on just by looking at the code, but let's do it over the serial port. So you can write serial.begin and also 9600 baud. And this starts up the serial connection to the computer via the USB cable. And now once we're down here, we get the character from the Bluetooth, and then we can print this to the serial monitor on the computer via the USB cable. So we do serial.print ln, so make it into a new line, and then just input. So this way we can sniff what is actually being switched down here. Let's upload this. And I will reconnect to the Bluetooth. And we will open the serial monitor. And it's just sending out garbage. So let's remove this and try again. So now it is actually doing what it's supposed to. Okay, so I figured out what the problem is. It's not really that difficult. As I mentioned, a lot of times when you use the read call, it will just block until you have some data to receive. But apparently it doesn't do that in Arduino. It returns -1 if there is nothing to read. This actually means that we doesn't have to check for availability before we do it. And also that this is not going to work because it reads far too fast. So I'm sorry about that, but there is an easy fix. We could also fix this part, but I don't think it's worth it. We'll just remove it and use the first method that I showed you. So just remove the default entirely and make a case 0. And now it should work, hopefully. Actually, we can just get rid of that. Oops. Yeah. 0, he said. So that is done uploading. And let's try again. So let's see if we have better luck this time. We'll connect. And then we'll move backwards. Yeah, it works. And still, as soon as we release the button, it receives a 0 and sets the motor to stop. How about this should be left, yeah, and right, yeah. So if you didn't see the previous video, this is the front of the car, and it has a single wheel in the back. So I think now we can get it on the ground and test it properly. So here we have it on the floor, and it's actually quicker than I thought it would be. But I also have a problem with the rear wheel. I was a little worried that it might not have enough traction, and it doesn't. So if I turn, you can see it's pointing to the side, and if I move forward, it doesn't straighten out, it just keeps going around in a circle. But in reverse, it works pretty well. But at least it's got enough torque to do a burnout. So I'll try to fix the rear wheel, and then I'll come back. I don't know if you can see it on the camera, but I went and put some PVC glue on the rear wheel here, a thick layer, and then I let it cure. And it's kind of soft, plasticky or rubbery when it's cured, and it looks like it has a lot more traction now. So let's try it again. Nah, still not. So guess what? We can fix that very quickly just by changing the orientation of the car. Since I made it, I can just decide that now this is the rear and this is the front. Because it seems to track a lot better when we're pushing against the wheel instead of pulling it. So we can just change the names of the functions so that forwards becomes backwards and backwards becomes forwards. So I went and changed that and uploaded the new code. So now this is forwards and this is backwards. And we can turn, and then we can just drive forwards. Of course, we still have the problem that if we turn and then we try to go backwards, it will just keep turning. And we can do backwards donuts. So not as good handling as I have hoped, but then again, I made it, so what do you expect? But I think it turned out very nice actually, and it didn't take that long to make it either. So I think this will be it for this video. It's probably plenty long already. But maybe in another video we can make it so it has acceleration, so it won't just go full speed when you press the button. So it will ramp slowly up to speed. Or perhaps we could make use of these buttons to set the speed, and maybe also do other functions. And also in the end I want to make it autonomous so that it can drive around by itself and detect objects and avoid them using the ultrasonic sensors. But for that I think I might have to change the handling. I'm thinking of going with tracks like a dozer or a tank or something, because that should give a lot better handling than this. It'll be responding instantly. So thanks for watching this video, and if you liked it, please give it a thumbs up. If you want the source code for the Arduino or the STL files for the 3D prints, I'll put links in the description of where to get them. So, see ya!